Okay, hello everyone. One more time. It's me, Kateřina Peková. I'm Tech Community Manager at STRV. I'm really happy that I can welcome you all here, and it's a great numbers, and we have a great show up after the summer break. And this is our 10th online event in this year and in these strange times. So welcome to the Backend Talk. Firstly, I would just like to tell you a few rules or how it's going to be organized. As you can see, you have many options how to interact with us, so please do so. We will be more than happy to receive any reactions. If you want to ask any live questions, just raise your hand. You can find this option under the participants section. So you can raise your hand and we will call you up and then unmute you, and you can ask any questions you would like, or you can write us in the chat section. You can also connect there with anyone from the participants, with the speaker, moderator, or with myself. So you can do that as well, or you can just react by applauding or put a thumbs up. Everything is more than welcome. Okay, so I think that's it. Now I just want to do a quick introduction. Firstly, I would like to introduce our speaker, Galin Kostov, our backend developer at STRV. Along with him, Allan Jorge, his colleague from the backend department, who will be moderating this whole event. And also let me introduce Michal Klečko, our backend platform lead, whom I would like to give a word right now. Thank you, guys. Enjoy.
Hello, everyone. So I'm Michael, backend lead at STRV. And I would like to welcome you as well on this online meetup. Before we will start, I would like to share a little bit of marketing for our backend team, so I hope you don't mind. We are currently hiring backend developers, mainly focused on .NET Core or Node.js, but also we are looking for some Ruby developers, specifically Ruby on Rails. So if you are interested or you know about someone, we will be more than happy to welcome you here. Feel free to check out strv.com. Okay, so that was the little bit of marketing I mentioned, and now back to the meetup. I would like to introduce Galin, our great backend developer, who will be speaking about their journey into Kubernetes. Please enjoy. Feel free to ask any questions, share thoughts, or interact in any other way. Thank you.
Hello, is it my turn? Hey guys, I would just launch a poll that I would like you to fill in, just so I can see what is the overall knowledge level of DevOps and Kubernetes, so I know how technical I can go into speaking and so on. There is one poll right now. You don't have to fill it right now, but like kind of in the next minute or two. And let me share my screen. Let me share the proper screen. Bam. Put my notes here. And that should go full screen. All right, I hope you can all see just the presentation now. And yeah, so this is gonna be a talk. It's not gonna be like a talk or presentation about some pro ninja Kubernetes setup and so on. It's more gonna be a talk about how we started with Kubernetes on a greenfield project that I just started working on with some of my colleagues, and we kind of had to make the choice into what container orchestration tool we had to use, and how we made our choice to use Kubernetes, and actually the more interesting part of how our usage of it evolved over time and how the infrastructure setup evolved over time. So how did we land to use this choice? Essentially, initially you have to choose the cloud provider, right? We knew that we are gonna use Docker because, well, who doesn't nowadays? And let me look at the poll. Okay, most of the people are good knowledge. Let me launch another one because we love polls, right? Why not? If you want to fill it in. All right. Sorry for this interruption. Let me go back to the presentation. So how did we make the choice of the cloud provider? I mean, there are various options out there. Some of the most famous are like Google Cloud and AWS, DigitalOcean, or Azure. No, I'm just kidding. Nobody uses that. And like in comparison, AWS offers a lot more container management possibilities, like the engine, the Kubernetes engine they have, the Elastic Container Service, Batch, App Mesh, like a bunch of other stuff. So AWS is naturally the first choice. But we had to take other factors into consideration. First of all, we use Firebase for a bunch of other features like authentication and so on. And Firebase is a Google product, right? So essentially, Firebase has a GCP project like under the hood. So that was a major factor for us choosing GCP. And another thing was that our client wanted to use GCP for pricing reasons. So it was quite an easy choice, actually. And then since we had the cloud provider choice, we had to go into the choice of the container management tool. And Google Cloud is not that doesn't provide that many options. The two main one are like GKE, like the Kubernetes engine, and there was I think the App engine. But yeah, like essentially. Also, I really wanted to use Kubernetes. Like just a month before that, I had read the book about cloud native with Kubernetes. So I was like, yeah, I'm gonna have like an opportunity to use Kubernetes finally. I'm gonna be one of the cool kids. So yeah, that's how we landed to using to the choice of Kubernetes. Now, the last question was, do we use a self-managed cluster or do we use like a cloud provider managed cluster? And yeah, like the self-managed cluster is a lot more fun. You learn a lot more stuff. Like for example, I've been dealing with Rancher a lot, and these are all good things. But when you think of time and when you have to develop a whole app around this, because the infrastructure is actually not the main thing that the client cares about, you gotta go for something that will just give you more speed initially in the project. So yeah, that was kind of, it was a pretty straightforward choice of using the managed service instead of managing it ourselves. And now to go more into details of how our journey went, or like, yeah, our learning curve, just a few overview points. It was very easy to start with. I mean, because it's a managed service, so we didn't have to do any cluster administration. Just a few clicks in the Google Cloud UI and you have the cluster ready. Putting in the credit card and you know, soon you're gonna be charged a lot. But anyway, The basic infrastructure setup was pretty easy to start with. It took us like a day to have the initial thing, but overall, like not overall, but eventually throughout uh, the time, um, these are some of the bumps that we encountered, like how to deal with the load balancing, the namespaces and the environment separation, storage, how to go cheaper on storage and stuff, and how to, sorry, some windows are popping up, how to tell which pods to go where, to put what, if you know what I mean. Some lame jokes around. Uh, and last but not least, the certifications for HTTPS and our DNS. These are the main points where we stumbled upon some issues. And now let's go more into details of what actually happened. As I mentioned, the initial setup was pretty straightforward. We started with one single node because, I mean, we just had one app. We were just starting to develop the application. It was the beginning of the project. And because we want to have higher availability after all, I was like running 3 replicas of this app. It was the backend API. I was running 3 replicas on the single node, and suddenly I was running out of CPU, and I was like, "What the hell?" The problem was twofold. First was the Kubernetes CPU management paradigm, and the second was that I didn't account for all the cluster, like system related pods that Kubernetes actually is running. It was the first time I was using a managed service, so I was thinking that they will not be kind of loaded onto my VMs, onto my nodes, all these system related pods that Kubernetes runs for data collection, internal DNS, certification management, and so on. I thought there will be somewhere in the void Google taking care of that. Well, no, they were all placed on my node, and that was taking like, I don't know, half of the resources of my teeny tiny nodes that I was using. And that was the first part of the problem. The second one was that how Kubernetes manages the CPU allocation. The CPU size is counted in milli-CPUs. And basically, when you apply some CPU a limit on the pod, that how much CPU the pod can use, you kind of give it like, let's say 100 M, like 100 milli CPUs, and your CPU will always be considered as 1,000, no matter whether it's 1 gigahertz, 2 gigahertz, whatever. It will always be 1,000 milli CPUs, or at least that's how I understand it. So correct me if I'm wrong. So essentially, I was like giving certain amount to my pods, and they were just grabbing this, and together with the system pods, the node was running out of CPU. So in order to run 3 replicas, what do? We need some more advanced setup, and spin up all the VMs, right? Just hog more hardware into the infrastructure. It's gonna solve all the solutions, right? Essentially, I just spun up one more node, and this is the initial setup that we ended up like with after 2 days. Nothing very sophisticated. I, I'm not sure if you can see my mouse, but my cursor. But anyway, there we had like a dedicated Postgres database instance, and then we had 2 virtual machines with our load balancer, and running 3 pods in total to get like high availability. That was very simple, straightforward setup that we started with. Essentially, as I mentioned, we had the dedicated Postgres instance. I was thinking like, like a whole dedicated instance for dev and for the database, for dev and staging. Eventually, when we're gonna have staging, it's gonna be kind of pricey because we don't need a whole dedicated instance for development environment. So I found out that we can move the containers, like we can move the databases into pods, like in the cluster, and it's gonna be cheaper this way because like storage is cheap, but running the actual instance that runs the database for that storage isn't cheap. And as a good cloud architect, I should strive for cost optimization, right? So yeah, I found out that actually I can use like Kubernetes has the concept of persistent storage. Basically, you can mount a chunk of persistent storage behind a given pod, and even if you restart the pod, the storage is not gonna be erased because the pods are ephemeral, which means like they keep their memory only while they live. When they're restarted, they lose their stored memory. So yeah, I moved. We also added Redis to the whole infrastructure. I moved the Postgres and Redis into containers, and at that point we also had the staging environment already. So in total, 4 databases, Postgres and Redis for each dev and for staging. And I mounted the persistent storage under these databases. And a month later, the databases were empty. What happened? Turns out that Kubernetes restarts the pods just kind of, what was the word? For maintenance reasons, basically, if the pod hasn't been restarted in a month or so, Kubernetes will automatically restart it. So 2 months in a row, we lost our dev database like that. And I was like, what the hell? I mounted persistent storage. Why is that? Why is the data being lost? Turned out that there was a teeny tiny small syntax issue in the configuration that I was putting that was not mounting correctly. So the lesson of the day is, after you mount persistent storage behind your pod, do add some data and do restart the pod right away, just so you can see whether your persistent storage mechanism is working or not. So it doesn't have, so you don't end up losing your data, just like we did. Next topic where we stumbled upon unknown issues was like our certificates and DNS. So we had just to clarify, like Google domains, like within a GCP project, you have Cloud DNS as a service. And then Google Domains is like a whole other service. So Google Domains is like a domain registrar, and it also offers domain name server configuration, whereas the Google Cloud DNS is only domain name server configurations. So we had our domain registered with Google Domains, and we also had our domain name servers configurations in there, and everything was working fine. We set up our TLS or certificates with a Kubernetes tool called Cert Manager. Everything was flawless, very easy setup. Our HTTPS traffic was working right away, but 3 months later, it was not working out of a sudden, and turned out that the certificate, even though Cert Manager is taking care of auto renewing the certificates, and I was kind of calm on that side. 3 months later, the certificate was not working. Turned out that Google Domains does not have open APIs because Cert Manager, when it renews the certificates, it needs to do DNS record sets injection to the domain name servers. So every 3 months, you'll just inject the new configuration to the name servers, but Google Domains doesn't have open APIs for this, but Cloud DNS does have. So essentially, we had to move all our domain name configurations onto Cloud DNS. That's a thing to keep in mind. Like, we still have our domain registered with Google Domains, but we have all our DNS configurations within Cloud DNS. Next thing, essentially at some point, we wanted to separate. We also had production already, so we wanted to separate dev from staging from production. And the Kubernetes namespaces are very good for that. What they are in essence is like a logical way of separating environments. And when you have different environments, you need to balance the load between the environments, right? Turned out though that the external load balancers are not namespace aware. So how do we separate the environments then? I don't want to run a load balancer per environment because that's going to be quite pricey. Like, load balancers are expensive. And essentially, we ended up having only the default namespace of Kubernetes and a separate one, which is for production, and just 2 load balancers for that. Kubernetes provides has this concept of services, which are they're like internal load balancers, if I can say it that way. Like, they can work on internal DNS or node ports, but they can also be exposed as external load balancers. So essentially, that's what I did for our default namespace. Just setting up an internal Kubernetes service and exposing it as a load balancer. Just kind of from one side to cut costs, from another side to kind of dig more into the different things that Kubernetes provides. Yeah. So how did we handle the continuous integration and deployment? There are different tools for Kubernetes to handle, because essentially when you have different environments, you will want to change some variables into your deployment configuration files, right, per environment. And you don't want to have 3 separate files or like a separate file for each environment. And Customize is one of the more famous ones. And I kind of tried to use it, but it was kind of confusing for me. I don't know, maybe I'm just slow. Nature didn't give me, I'm not the nature gifted. So maybe that's why I couldn't get it quite well. but I already had experience with Bash, and our requirements, what we had to do was not so sophisticated. So after spending half a day trying to configure, customize for our project, I was like, you know what, screw that, I'm just gonna use Bash. And in this code snippet that I'm showing here, that's basically the capitalized placeholders variables are the ones that we actually replace for different environment deployments. And yeah, with simple Bash commands, that works quite well. Yeah, next thing that we had to take care of was monitoring. I mean, monitoring is important for any production environment, right? And when you talk Kubernetes and monitoring, usually people immediately talk Prometheus and Grafana. Prometheus for data collection and Grafana for visualization. And I was immediately thinking the same thing, but it had to be set up manually, right? And setting up Prometheus wasn't a peach, so to say. Like setting up the actual service within the cluster was not a problem, but afterwards you have to set up a bunch of data collection rules, and there are some templates for that, but essentially for your own needs you have to have your own custom things. And because of time constraints, because when in software development there is never enough time, especially for infrastructure, especially when the client wants more features. So I just resorted to setting up the Google Cloud native monitoring tool, and that was quite a peach. Easy to set up. Alerts were right there for me to configure. They were working straight out of the box. Yeah, nicely done. Next thing, this was one of my favorite parts, dealing with Kubernetes. It's quite a sophisticated, and I just like it a lot. We already talked about milli CPUs, right? So where was I? Yeah. As we started with one node, then we added one more. Then we added another service to our to our system, and we had like the databases now running within Kubernetes. Basically, it was and then we had 3 different environments. So that's like I don't know, 15 different pods, maybe more. I was just adding more and more nodes to the cluster, and at some point we had like 5 nodes, but I was like, okay, just adding more nodes in the future is just gonna, for now it's solving the problem, but eventually it's gonna be actually a hassle. So I was thinking, okay, we have the namespaces for environment separations, but it would be better if we have production at least separated also physically, like in terms of nodes from the other environments. And then I stumbled upon node pools. So node pools are basically, well, a pool of nodes. Is the concept is the concept in Kubernetes of grouping servers. And the thing is that you can, within one node pool, you can only have one type of nodes. So if you want to have a server with 1 gigahertz CPU and another with 2 gigahertz and another which is, I don't know, graphics card optimized, then you have to have 3 different node pools for each one of these. So it was a bit of a whole day of work. Like I had to create the new node pool, drain all or the desired pods from the first one, start them up on the new node pool, also had to be aware of the fact that everything has to be without downtime for production. So yeah, that was a quite of an interesting exercise. And the other part, now that I have two different node pools and one of them is dedicated just for production, I need to tell Kubernetes somehow to not spin up pods that are for development or staging, to not spin them on the production nodes. And that's where taints come into play. It basically is kind of telling that, okay, this node has this taint, and unless the pod that you're spinning up has the toleration for this taint, do not spin it on this node. I mean, it can get more complicated than that, but this is the basic definition of it. So that's how I made it the production nodes dedicated for production pods. And then at some point earlier in time, I noticed that we ended up in a scenario where a bunch of pods from a single environment were all placed within a single node. So we had like 3 or 4 different nodes, but let's say all the pods for staging for the API, for example, were running on one instance, and that kind of defies the high availability, because okay, we have 3 different replicas of a service, but if they're all on the same node, I mean, what's the point? So then come the pod affinity and pod anti-affinity come into play, and they're basically kind of like a magnet. The rules for affinity and anti-affinity is kind of like magnets repelling each other. Basically, in this code snippet on the slide, I'm telling this pod, when it's being started, do not, or since it's preferred during scheduling, it means that try not to start this pod on a node which already has a pod running with the given expressions. But if there is no other possibility, then it's fine. So that's how I told Kubernetes always to try to separate my pods like among as many possible nodes. Tools that helped me a lot throughout this journey was Lens. That's a very, very good IDE / UI tool for Kubernetes. It gives a very good overview of what's going on in your cluster, like secrets, config maps, different servers, load balancers, all your pods, basically everything. And you can also do changes on the cluster from there, spinning, like increasing the number of pods and starting, stopping stuff, basically everything. And if you have Prometheus configured, you can also see a lot of monitoring graphs in Lens. We don't have Prometheus configured, so we can make use of that, but yeah. K8s is a CLI tool for switching between namespaces. It's quite convenient, because when I'm running commands from the terminal, and I always need to make sure that they're run in the, like if I'm spinning new pods or making some changes on the config maps, I need to make sure I'm making it in the correct namespace. That, for example, I'm not running something in production that I don't want to. And if, like with K8s, I don't have to add the namespace parameter to the terminal command every time. And the the kubectl is like the CLI tool for Kubernetes, the default one. And it actually has a very, very detailed and very well written documentation right within the tool. So if you are unsure, like when you make this kind of configurations, when you're writing your Kubernetes manifest file, and you're not sure of some parameter, you can totally find everything through kubectl explain, and it will be quite well explained. You don't have to go browse on the internet. That's the system that we ended up with, that we have currently. You can see the difference with the with the initial and this one. I've put little muscles here because these pods are actually buffed. They are almost double the size, if not for sure double the size of CPU and memory that is allocated to them compared to the ones in development and staging. But essentially the production environment is a lot simpler if you look at it that way. We have the Postgres and Redis dedicated instances. We have our API service, and we have another service that does other stuff. And we run each one kind of like a type of a service running a single replica of a type of a service running per node. Then on our default namespace, which encompasses the dev and staging, it's a bit of a mess, but I'm working on, when I have time, separating that into two different namespaces. The load balancing kind of got messy because like it's easy to set up the load balancing for the API, but the dev and staging databases, we also want to have manual access to them. Like, for example, if I want to check some data, or like if the QA wants to check some data, and stuff like this. So I had to essentially open public access to them, but I didn't want to set up a whole extra load balancer for cost optimization reasons, as I was speaking earlier. So then the load balancer service came into play very neatly. And I just set up because it cannot kind of, I don't know if that's a best practice or that's how things actually should work. But what I found out from researching Kubernetes, I cannot point directly my load balancer to my actual pod. I need to use an internal service, either, well, I need to use a cluster IP, or I can use a different type of internal service called node port, and then expose that publicly, and then I can have direct access from, then this service is gonna act as a load balancer, and then the connection from the public internet to my pod will be a lot shorter and direct, but we run our nodes, like the virtual machines are running within like a private network on the cloud, so it's not publicly accessible because of security reasons too. So then I had to do an extra step in the hop of the traffic to like have the load balancer exposed, and then this load balancer pointing to the cluster IP, and then the cluster IP pointing to the actual pod. And then our Postgres has, as I mentioned earlier, mounted persistent storage underneath, and the persistent storage is actually stored on the cloud buckets. So they are not directly related in any way to the actual virtual machines. So it's pretty neat. And yeah, that's all, folks. And now let the questions begin. Not sure. Should I, Katka, if you want to jump in, or Alan? There's a lot of questions here. I'm not sure.
Yeah, I will jump in.
Okay.
So, hello everyone. I'm Alan, also one of the backend developers here. So we will now go through all the questions. I think I will leave the one regarding what we use at survey for later, because right now we are like fresh regarding the talk. So let me see. Oh yeah, so Yaroslav, he said, oh, since you were talking, Galin, about GCP and AWS,
Yeah.
we're also trying to have your own server solution that could handle all the work. So I think like just doing everything on your own.
Like to host the servers on our own machines. If I understand the question in that way, then I was never even thinking about that. Would be just too much of a pain in the ass setting up all the networking and fault tolerance and security. Like whenever I think of starting a project, even if it's my own, I immediately think cloud because there is enough free options out there, and it's just way easier. I don't have to deal with system administration.
Perfect, perfect. So Yaroslav, if you have any further questions, just leave them in the chat and we'll go over them. So another one is from Thomas. He asked, what was the biggest pain from your point of like on this whole journey?
Maybe like debugging stuff, because when you write an application and you do some coding, you can kind of debug what's going on in the code while you run the program. But here it's all I mean, not just in Kubernetes but in any cloud infrastructure setup. When you start something up and something's not running or like not working correctly, like what do? You have to dig into some logs, or like where do you find the information? And especially if you are new, like I was new into Kubernetes, I just have to like dig a lot into forums online, read a lot of documentation, read a lot of like what is this parameter for. Especially like when I had to find out the problem behind the persistent storage not working, which turned out to be like literally a single word put wrong in the string of configuration. It took me like a whole day to figure just that out. So yeah.
And another question from Thomas, having like different dev and production environments, did you run into any problem? Like it runs in dev and doesn't work in prod? Do you have like anything like this?
Not really. Like that's one very cool part of Kubernetes that, or at least in my experience, um, everything is kind of identical, and you just replicate it among environments. Of course, you change some things depending on how sophisticated your setup is. Like for example, in dev, we only run one replica of the API. In staging, we run two. In production, we run three, right? So it's like little changes in the configuration file, but at the end of the day, the configuration file is the same, and you just change some small values here and there. So it's kind of like you have it once and you just like splash it multiple times across environments. So there is no much difference apart from the databases. Yeah.
Perfect. So another one. This one is from Andre. I hope I pronounced her name correctly. Does the project assumes any kind of redundancy on the database, like Postgres, like at the database level?
So I'm gonna start from production. Since we use dedicated Postgres and dedicated Redis instances, they are managed by Google Cloud. So they offer like 99.99 whatever percent redundancy and fault tolerance, and that's the beauty of managed services in the cloud, right? You don't have to worry about fault tolerance and networking and security. You just start it up and use it. So in terms of production, we also, another thing is that there is automated read replica and automated backups like nightly. So if something goes bananas, all of this is gonna trigger in automatically, and everything is gonna be back on track within minutes. And that's just like very easy to set up from the Google Cloud UI. The same goes for AWS or probably for more, at least the major cloud providers. Then on the dev and staging environments, like, I mean, we don't care that much if we lose the data on dev, for example, because after all, it's just for development. The only way we're gonna like the only way we're gonna lose the data is if the bucket that we use as a persistent storage, I don't know, evaporates or gets lost or somebody deletes it. And then since we run the databases within Kubernetes pods, like Kubernetes takes care of them running constantly. So essentially, I don't have to do any management work at all, and I can happily focus on development.
Okay, perfect. We have another question, but this one I think is going to be good for the open discussion panel. Yeah. So I want to now introduce what is going to happen. We had this idea of having like this panel discussion, so we can, not just have the talk and that is it. So basically, we have some people here from SRV, like Josef and Josef. They're just watching us, but they will join us as well. And from there, we will talk about SRV. We'll talk about development in general, about DevOps, and we can dig deep into whatever you guys want. So basically, if you guys want to join us, you can either drop your question or not even questions. You can make comments in in the chat, or you can raise your hand and join us live if you would rather talk instead of chatting. So it's basically should be like a say discussion, conversation, not just like questions and answers. So everyone is welcome to join. So I think we can go back first and talk a little bit about SRV. So I think Yaroslav had a question regarding if you are planning on replacing Node.js with .NET Core, and what was the let's say the reason behind this. If Michał, you're here with us, I think you are the best person to get into this topic.
I'm still here. And as I replied in the chat, we are not replacing Node.js with .NET Core. We just extended our existing tech stack with the .NET Core, but Node.js is still majority of our team, and we just consider this to be an addition. I shared in the chat also article about why we decided to expand with the .NET.
That's great. Perfect. Yeah, and there's one thing I like about Survey, that we are not just stuck with one technology. I think we try to have, the best tool for the job. So we have a project that are using Python. We have projects on Ruby on Rails. I think it's less about the technology and more about how we can tackle the problems down.
Exactly.
Basically, if there is a client that wants to do something in Golang or probably even in Rust, we will find a way to accommodate their needs. I can tell you that.
Yeah, exactly. Let me see. Oh yeah, so yeah, it's basically that regarding the languages. So I have one question, Galin, how did you, because I myself, I'm trying to get more into DevOps, and right now everyone is just talking about K8s or Kubernetes for some people. How do you get started, because it's a lot of stuff, people are saying oh, you have 1,000 of plugins and everything. How do you get started? How do, for someone like me that's getting started into DevOps, how can I start?
With DevOps in general, or particularly Kubernetes?
with both.
Little bit of
DevOps,
both.
like, yeah, I mean, I think eventually I will have to learn K8s. But like starting with DevOps and then moving to Kubernetes, like, how would you help me?
Yeah. Like I would say the first thing you have to do is when starting into DevOps, the first thing you need to do is learn Docker. Of course, there are other container tools out there, but let's just focus on the most used one, Docker. You just have to start doing that, and whatever application you have, you're developing locally, you just use Docker for that. That's just what's gonna give you the most experience. The other important thing I think is to learn how to do continuous integration and deployment, and you can easily use free offerings from some systems like GitHub Actions or Circle CI, where you just kind of learn the concepts of building your image, pushing it to the cloud, and then starting your service by pulling this image from the registry and starting the service. But the thing is that you just have to have a project to utilize for your DevOps learning needs. Like you cannot, at least in my experience, I cannot just like, I can read stuff, but you just need to practice it. Like I wanted to learn Kubernetes for a year or two, but I just kind of didn't get the opportunity for it. And now I just kind of got this project to work on, and that's how I started. But essentially, you can just start with Minikube. That's you can run it easily on your own computer. It's just a solution for a Kubernetes cluster that is like super small and super easy to use.
Yeah, that's great, because I myself, I try to take a look into K8s, but I have this problem that I was like, okay, I have this pet project of mine, but I think like that Kubernetes is way too big just for this project, you know?
Yeah, I feel
sometimes
you.
I feel like it's overwhelming, you know?
Yeah.
I don't know if the other guys had the same experience here, but for me, I was like, oh, I have just simple API. Like, how can I make Kubernetes, like all the trouble to setting up and having everything just for this? So when you have a pet project, I think it's really hard to come up with like a reason to use, basically.
Like for pet projects, I would say, I think like Juan also asked, when not to use Kubernetes. It's, I don't know, like when you can, like the big cloud providers, they offer enough container management tools. So Kubernetes would not be my first choice unless I know that the project will grow. If it's like a small API, I would just use Elastic Container Service from AWS, for example, or yeah, something like that. Like Kubernetes is kind of, it's very, very hyped, but I don't think, unless you know that your project is going to grow, essentially, you don't need to use it.
Sounds like, oh, you can go, Jozef. Sorry.
Yeah, honestly, I think price is also like big decision point, because, for example, on AWS, if you start a managed EKS cluster, you are paying immediately $75 per managed services only. And then you have to attach worker instances, or you have to run your containers on their Fargate solution, which is like managed container runtime. But I think this is the big decision point, like whether you what's your budget on and how customizable you want to have it. But if you want to start, I would recommend like just install Docker for desktop. You can enable Kubernetes on your desktop and write your Docker image, try to run it locally, and then try to install ingress controller, try to load balance it. And that was probably for me the best way how to start.
That's great. I also know like this platform that was acquired by O'Reilly. I think it's called Catacode or something like that. That they give you a lot of They give you your whole, let's say, Docker image and everything just online. So you have like this online console where you can type the comments and everything's happening on the cloud, of course. So I was going through it, and it can help a lot. Like they have some exercise that you can do, and you can start like building your, like, say, cloud on top of K8s without having to have the idea before. So I'm still going through them, and it's actually pretty good. I will link it in the chat later. You guys should give it a try. Like, who else is like me that's just getting started? It's really helpful.
When you mentioned the platform that works on top of AWS, I just remembered Heroku. It all runs on AWS, but it's super abstracted from. You are abstracted from AWS, and they have decent, I would say, options for free services that you can utilize. So if you have a pet project, then you have no idea of DevOps and how to put things online, I think Heroku is a very, very good option. At least the free parts, because and they have good documentation as well.
Yeah, I would maybe like to note here that Heroku is, as you said, it's very good for pet projects or for like from the beginning. But once the project gets bigger, then it can get like very, very expensive. And I'm saying that from experience. So I would definitely recommend to then move to either AWS or GCP or some cloud provider, so it can get much less expensive.
Yeah, regarding like pricing, do you guys monitor like how much you're spending on everything? What we should look for, when things are on fire? Because from what I understood, like you have a lot of separated components, and they can cost like just by themselves. How is the pricing? Like, how do you guys handle it?
Well, in my case, the client is paying. So
it was like,
and he gave me the green light. So I was like, we need more servers. He's like, fine, whatever. And I'm like, yeah. That's like the dream of any DevOps person. Unlimited cash. Yeah, but like there are nitty-gritty stuff that you should be aware of. Like, as I said, load balancers are expensive. Database instances are also expensive. So whatever you can kind of not outsource, but kind of move to something like a container or something within Kubernetes in this case, that would be a better option to cut on costs.
Oh, that's really cool. Good to know. Because that's one thing that really scares me off, is like the pricing.
Yeah.
So you have to be really careful when estimating how much you're going to spend. I think sorry.
Yeah, in our case, like I think on AWS you can count it pretty well, because what you usually need is like managed cluster, then EC2 instance, whatever size you want. But as Galin said, like what surprised me was that your worker instances are immediately occupied by system Kubernetes pods. And for example, on AWS, there's this hidden limit, or the limit that I didn't know about, that, for example, if you have T2 small instance, you can have just 13 pods running on that instance, because every pod basically needs IP address, and they have limitation how many network interfaces can be attached to that EC2 instance. So we were very, very soon hit that small limit. So
I can imagine.
That's something to be aware of.
I think there was a question. Thomas was asking if we're using Helm or other package manager. No, we haven't gone to that stage yet. There are some very cool things that Helm can offer, but I think for example, would be, since we had problems spinning up Prometheus and like other stuff, I think Helm can solve this pretty easily, but just didn't have the need so far, to be honest. Maybe I know Joshka is also running Kubernetes. Maybe I don't know, are you using Helm?
Actually, we are we are not, because you have to install Helm Tiller into cluster, which has quite high privileges what it can do in the cluster, because it can install other charts, Helm charts. And I'm working on a project where security is like priority, so we didn't even want to have that Tiller running in the cluster, but people are using it quite often.
Yeah.
I'm seeing it a lot.
That was actually my next thing I wanted to say, is that everybody kind of, or there's a big hype around Helm, because it just gives you very easy offers to spin different services. But I've read a lot on different forums and stuff that, as Joshka said, it requires very high privileges to the cluster, and there are some security flaws here and there. So if you don't research well enough about Helm, you might end up opening some security door that you don't know about into your cluster. So it's
just
kind
like
of a
an
knife
NPM,
with two
basically.
edges. Yeah, exactly. Like it's a knife with two edges, you know.
But do you do they have something like, we have, I forgot the name, that integrated into NPM that can search for vulnerabilities and this kind of stuff? Do you guys know if like they have the security point that you can search for, you know, vulnerabilities in the package or whatever?
I'm not sure.
Because I have no idea.
I think that's something different. Like usually what you do is when you build Docker image, you check vulnerabilities in the Docker image. But that Tyler is something that's running in the cluster and has like privileges to like move things around in the cluster and like deploy new stuff into the cluster. So you may have something like hosting, like intrusion detection system in the cluster to check for whether some service is doing something strange or some anomalies, but
that's already like sophisticated stuff.
Yeah, I just found out that Sneak is the same company that works for NPM, like doing all the security stuff. They also are getting to Kubernetes. So right now they have like Helm charts for security, like regarding misconfiguration. Really cool, really cool. One less thing to shoot ourselves in the foot.
Yeah, I can recommend Falco. It's like open source tool that you basically deploy container in the cluster and you give it like higher privileges, and it can check other containers whether they are doing.
Nice.
And you can like define what you are watching for, whether it's access. For example, if someone opens terminal in the container, it can like alert you.
That's really useful.
There were a couple of comments from IO. IO. So yeah, like Heroku is getting expensive when you grow, but that's why you don't grow with Heroku, you know. When you, I don't know, like in general, I am a person who likes to manage his own stuff. So for me, Heroku is like kind of a starting point. I just need to push this MVP out, and then when I have more time, I'll move into another platform. And in terms of Terraform, I wanted to use it, but I have never used it, so I have no experience with it. Essentially, I wanted to use it for this project, but when the project was starting, I was the only backend on the team, so I had to do infrastructure, I had to develop the API, I had to configure the database, like I had to do everything. And since I had no experience with Terraform, I just concluded it's gonna take me too much time, and my project manager is gonna eat my head. So I was like, okay, maybe in the future, but definitely I wanna do it, like use Terraform, because we're getting to the point where we have quite a few moving parts of the infrastructure, and I'm the only one who knows about all of them. So I'm a bottleneck in the knowledge of the infrastructure, right? So if a bus hits me tomorrow, it's gonna be like kind of bad for the other guys. And Terraform can totally like get rid of this problem, because we'll have all the infrastructure documented.
We use Terraform on our project. and I recommend doing that. Like they have nice packages like Terraform modules where you can set up VPC easily, the whole EKS cluster very easily. It's like few lines of code, and you have a running EKS cluster. So definitely recommend it, and something.
By the way, are you on your project? Are you using EKS or you're managing the cluster yourself?
No, we are using EKS. We have two EKS clusters, like one for development environments and one for production environment.
And
Okay,
what
so
is
you
it
have
again?
Sorry?
Sorry, what is Zk?
EKS is like managed Kubernetes service from AWS. So basically, every cloud has its own version of this. Azure has AKS, and so basically with Kubernetes, you have like master servers and worker servers, and with master servers, either you deploy master servers on your own. There are tools for that, like K8s or something like that, or you pay for that, and like AWS does it for you, and like monitors all the master servers and monitors those like system parts of Kubernetes, and you are only working paying for those worker servers or those workloads that you are putting in.
It's kind of like renting a virtual machine, like an instance, and then installing the database on it, and then managing the database yourself, versus just renting a managed database instance from the cloud provider. So it's just like a level of abstraction.
Yeah, I see. Just having more as a service than doing everything
like,
on your own.
I have a friend who is like managing, but he's a total geek. He's managing the Kubernetes cluster himself, and they have like over 100 services running there. They have like 1,000 pods and shit. But his full-time job is managing this cluster, you know.
He definitely does that for breakfast.
Yeah.
And the same for upgrades. Like if you have managed master service in AWS, you have just one click button, like upgrade cluster. But if you are managing it on your own, like it's like
some nice without a zip, right?
And if you set up automated upgrades, you don't even need to know something happened.
Okay, I'm sold.
Yeah.
And I think Pavel had a question, like, what made you choose K8s over Docker Swarm?
Like, Docker Swarm is kind of dying. I haven't ever used it, so I cannot give you like a good opinion about it. I just know it's or IO says it's even dead. First of all, I wanted to do Kubernetes because it's hyped and it's cool. And second of all, Google Cloud just provides the managed service there. There is no managed service for Docker Swarm on Google, so it was that was our choice.
On our project, we used Docker Swarm at first, and we transferred from Docker Swarm to Kubernetes. And the reason was that you have like of Docker Swarm, you had two options. Either you are using that community edition, that's for free, or you have like Docker Enterprise, that's their solution. And we used that community edition, but at some point we hit its limits because we needed to deploy something into. We needed to deploy that host into intrusion detection system, and they used like image of machine that didn't allow to install that on that machine. So it was like, okay, so now it's a good time to switch over because it's dying anyway. So,
but was it like painful, the process of switching, or do they offer some tools that can make it easier?
I would say it was not easy, but it wasn't that hard. Once you have it in Docker image, it's quite easy to move it anywhere. Either are you whatever orchestration engine you are using. I think once you have Docker image, it's quite easy.
That's the beauty of containers.
Yes. And I have a question, like you, Galin, you talked about like Rancher. I was like going through their documentation. I got a bit lost. Like, what do you use it for? And do you have like any other like options besides Rancher? How does it
Yeah, so
work?
Rancher is just another container orchestration tool like Kubernetes or like, okay, for maybe if there are other people here who are not so acknowledged with containers and you're getting lost. So essentially you have like a container in which you're running an application, right? And you need to run that container on some server, or like if you're in a cloud on some virtual machine, but essentially it's a server. And what happens if this container dies, you know? Like you need to log in and restart it or like whatever. So the container orchestration tool just abstracts all of this for you. You just plug your container and you go to sleep, you know? So Kubernetes is that, Ranchers is that, Docker Swarm is that, and so on. Like the newest version of Rancher is actually built on top of Kubernetes, but the previous one wasn't. But essentially, it's just a container orchestration tool.
I see. Yeah, I think like Kubernetes just like is the king now, right?
Yeah,
Everyone's moving to
and
it.
just like Io mentioned in the chat, Rancher is mainly Kubernetes management. So it gives, like right now, I don't know if there is some UI for Kubernetes. I think like default one. But for example, Rancher is kind of built on top of Kubernetes, and they offer very good UI for all of this. So it just makes the whole thing a lot simpler.
To hear that.
Yeah.
So do you guys have, sorry, not the the speakers. Do you guys from the chat, do you have any other questions, like something you guys want to know? If not, I think we are good with the panel. So thank you all. And now I will let Katka wrap it up for us. So thank you guys also for joining. And this panel was really good. I learned a lot.
Yeah, that was. Thank you for listening to me and my lame jokes.
Okay,
you,
hi
guys.
everyone. Thanks again to everyone who stayed for the panel. Huge thanks to our speaker, our panelists, and our moderator. I just want to say that we are hoping to plan another backend events pretty soon. Meanwhile, we have a lot of events on our pipeline until the Christmas. They are from front-end department, iOS, Android, and others. So, but hopefully the backend one will come soon as well. And since we want to be proud of everything we do, we're gonna send you a short, really short and brief feedback survey. So we will really appreciate if you let us know what you enjoyed. And especially, I'm really interested about the timing of the event. If you would prefer to do it earlier or later, because we know that the situation is still changing and a lot of people are still working or newly working from homes. So let us know what you prefer and we can adjust it to your needs and to your wishes. So I think that's all. Thank you again for coming and hopefully see you soon. Bye-bye.
Bye, everyone.
Take care.
Thank you guys. See y'all.
Bye-bye.